This is from the 2013 AP BC test. We have gravel that's going into an unprocessed lot coming in at this rate, G of T. And that's going to come between 0 and 8. Before they start processing the gravel, there's 500 tons already there, and it processes at 100 tons per hour. So first thing I want you to find is G prime of 5. So what you're going to do is just take your G of T, and we're going to figure out what that is, and you're going to have this when T is equal to 5, and you can do that directly in your calculator, and it works out to be negative 24.588. So what does that stand for? It told us G was measured in hours, so this is going to be the gravel is decreasing at that rate. So the rate at which the gravel is arriving is decreasing. Oh, what the heck happened there? Decreasing by 24.588 tons per hour at time equals 5. So the rate was originally in tons per hour. So when you do the rate of the rate, it's going to be tons per hour. So it's talking about how the rate is changing. So part B, find the total amount of unprocessed gravel that arrives at the plant during the operation of the workday. So our operation of the workday only goes from 0 to 8, and it only wants to know how much was arriving at the plant. So B, arriving at the plant would be from integral from 0 to 8 G of T dt, and that works out to be 825.551 tons. Now notice that's just the amount that arrives. Remember that we already had 500 there, and then we also have some processing. Part C. Is the amount of unprocessed gravel at the plant increasing or decreasing at T equals 5? Show your answers that lead to this. So let's see, G of 5 is equal to 98.1407, and remember that per hour we are going down by 100 because we're processing 100 tons per hour. So it is still decreasing at that point. So at time equals 5, the rate of unprocessed gravel is arriving at 98.140 tons per hour. And which at this point is less than it takes to process it. The plant processes more per hour than that. So the amount is decreasing. Part D. What is the maximum amount of unprocessed gravel at the point during the hours of operation on this workday? Okay, so we're going to talk about how much is being accumulated throughout the workday. So remember, before we started, there was already 500 tons in there. From 0 to 8, we are dropping it off like G of T, but we're also processing it 100 tons per hour. So now we have to look at where, if we want to know when this is going to be a maximum, we have to take the derivative of this, set it equal to 0. So that's going to be where G of T minus 100 is equal to 0. So that's asking where g of t is equal to 100. And if we use our graphing calculators, we'll find that g of t crosses the x-axis at 4.923. Now this is a closed system, so we have to check the endpoints. So at time equals 0, we knew there was 500 in there. At time equals 4.923, put it right in here and you'll figure out how much we have, which is 635.376. And we know at the end of the time, we have less gravel in there because now it's over 100, so it's going to start decreasing faster than what it was being put in. So our maximum is at time equals that. So the maximum amount of gravel is 63.5376 tons, and that happens at time equals 4.923. Okay, and lastly, we need to talk about how this one was scored. So the first point, which was A, you got 1 point for finding out what g prime of 5 was and 1 point for explaining what it was. Part B was 1 point for the integral, 1 point for the answer. Part C, you should have been comparing the amount at g of 5 to 100 and then giving a conclusion. In part D, you're looking for when a of t, and then looking where a prime of t is equal to 0, and then your answer and your justification. Okay, so 1A, remember that g was given by, it's actually g of x, not g of t, not g of x. So g of t is equal to 90 plus 45 cosine of t squared over 18. And they wanted us to approximate g prime at 5. And that's just going to be the derivative of this one. So you're going to do 900 plus 45 cosine of t squared